Hello my dears, a very good morning to all. So I think there were no classes, right? There were no classes 2-3 days for 2-3 days due to some personal reasons. Okay, actually I was not healthy those days. I was really tired and was a small fever also. So I couldn't prepare for the classes. I couldn't take the class. First of all, sorry for that. Okay. So now today we are going to discuss anyway in the last class we discussed about the concept of armature reaction, right? So there are a lot of problems in the armature reaction, especially what it will distort the original field flux as well as it will demagnetize the original field flux. So definitely this will lead to the dip in voltage, or there is a decrease in voltage in the induced EMF, right? Induced EMF will be reduced. The reason why there is an unequal distribution of what flux or there is an unequal flux density across the pole phases, so that the flux lines will be distorted, so that EMF will be distorted. EMF will be reduced. Today we are going to discuss another topic which is nothing but the commutation. Actually it is very difficult to understand the concept of commutation. Okay, anyway you can explain this commutation in many methods, but the easiest way I found is this is the diagram. Okay, this I will going to explain. So the meaning of commutation is nothing but, my dears, the reversal of current through the coil during the movement of the brushes. We know that, see my dears, suppose this is the armature. On the periphery of the armature there will be commutators, right? There will be commutator. Okay, and there will be commutators in the sense this is the commutator segment. This is the commutator segment. This commutator segment is made up of copper, and this is nothing but the insulation between two commutator segments. The insulation between two commutator segments, and this is nothing but our brush. This is nothing but our brush. And this is commutator segment. This is commutator segment. This is insulation, my dears. This is insulation. This is insulation. So what happened? The brush is stationary. The coil, that is the armature side, along with the commutator will move, will rotate, right? The brush is like this. The brush is like this, stationary, and it will continuously moving. It will continuously moving. This is the check. This is the case in which in the DC machine happens. This will rotate and the brushes will be stationary. So what happened means, suppose the motor is moving in this direction. Suppose the motor is moving in this direction means we may feel like the brushes will be moving towards left from right. Am I correct? The motor is moving this direction means the brush will be moving from this to this direction. Am I correct? The motor is moving in anti-clockwise means, as far as the concern of brush, the brush will move in the clockwise direction, correct? You can assume in that manner. So commutation is the process of simply what my dear, simply even though there is a changes in the current in the coil, okay, there will be always some fixed current, that is a 40 ampere, let it be 40 ampere. Any current you can assume, let be 40 ampere will be available at the output side. That means the reversal of, or in other words, the meaning of commutation is the reversal of current, in the coil, the reversal of current in the coil, and irrespective of that reversal, there is always a constant current or a unidirectional current which is available at the brushes is called the commutation. Okay, there will be changes in the, I will explain by using this diagram. Okay, and again I will come back to the definition, then only it will be more and more clear. Listen my dear, suppose these are coils. Coils in the sense, let it be take like a parallel path. Okay, it is very easy to assume like a parallel path. Let it be a parallel path. So definitely each parallel path will be what? We already know that each parallel path will be connected in parallel, and in which every coil is a bundled structure and which are connected in series. Am I correct? Suppose there are 400 conductors, 4 parallel paths. What it means? 400 by 4 will be 100. Each bundle consists of 100 windings. Am I correct? Each bundle consists of 100 windings, and that windings are connected in series, and each hundreds are connected in parallel. Okay, that is the concept of parallel path and the conductors connection. Okay, so let it be coil. For the simplicity, let be coil, not the parallel path. Okay, leave it that. Let be each coil. We know that each coil produces certain current. Am I right? Each coil will produce a certain current. Am I right? So let it be 20 ampere. Let it be 20 ampere. So let it be 20 ampere. Let it be 20 ampere. Okay, and this is the commutator segment. Okay, in which we are connected to the coils. Okay, and this is our collecting brush. This is our collecting brush. Say the brush is in this position. Suppose the brush is in this position, means each coil definitely will produce same amount of current, my dears, because in each parallel path there will be same induced EMF. Am I correct? There will be each parallel path, there will be same induced EMF. That means same current also. Correct? Same current also. So this is a parallel path, this is a parallel path, this is a parallel path. Or this is not a single conductor, my dears. This is so many conductors connected in series. Again, this is so many conductors connected in series. This is so many conductors connected in series. Okay. Anyway, what we are going to do is, we insert our brush, or the brush position, you assume it is here. It is here to mean that this is insulation and this is insulation. This is commutator segment. This is our brushes. Normally we are using brushes as carbon brushes, right? Copper brushes, etc. you can use. So this is our brush and this is our commutator. So these and these are conducting path, right? These and these are conducting path. So that if something is collected here, you can directly collect it across the outside or collect it to the outside by using this conducting path. That is why the conducting path can come in contact. So if the conducting path can come in contact, then anything you can collect it here, you can take it outside. You can take it as outside. Okay. So what happened here? You see, my dear. So this is a brush position. Okay. This is a brush position. So this is my current. Suppose a 40 ampere of current is coming due to a 20 ampere here, 20 ampere here, a 40 ampere come here, because in here it is a junction. So 20 plus 20 will sum up added to 40, and there will be the collection of 40 ampere. And what happened to the next diagram? The brush is slowly shifting, correct? It's not slowly actually. In the diagram it is slowly shifting, but it is a fast shifting actually. Okay, it is fastly rotating, the brush is shifting. So for the analysis purpose, what I am going to do is, I slowly moved my brush to a small portion left side, because the motor is moving towards the right side, means the brush will move towards left. It is a correct. It is a correct but concept. Okay, so if the coil is moving right, means if the brush will move towards left. Okay, so what happened? The brush will be slowly moving left. A small portion will be moving left. What happened, my dears? The current will be 40 ampere. There is no change in that. The current will be always 40 ampere. But what happened? See the concept of brush. The area of brush in contact with this commutator segment is very high, very large, and the area of brushes which is contacting with the commutator segment 2 is narrow. So what happened? A small amount of current will be flowing or collected by this side, this commutator segment, and this side, and a large amount of current will be collected by this side, and it will come again. So the overall current will be 35 plus 5 will be again 40 ampere. Again 40 ampere. But see the nature of the current here. Suppose this is 20 ampere, it come here like this. In order to make it 35 ampere, what is the current through this coil? It will be 15. Then only 20 plus 15 will make it to 35. If it is 15 means, here it is 20 ampere now. So 20 minus 5 will be make you this 15 ampere, correct? Simple arithmetic. So this is the 15 ampere current, and this is 20, 35, 5. Okay. So definitely there will be the sum like 40 ampere. And in the next case, it is exactly in midway between these two commutator segments, correct? That means equal portion will be shared by the brushes to each of the commutator segment. So what happened, my dears? 20 will be current, 20 will be the current, and here will be 0 current. Am I correct? This whole 20 will come here, this whole 20 will come here, and it will be collected here, it will be collected here, and the whole current will be collected here, and it will be 40. And in the next case, what happened? It is again moving towards the left. That means a small portion will be under this commutator segment, but a large portion will be under this commutator segment. So what happened? What happened? This will be collected more and this will be collected less. So similar to this condition, this will be collected more means say it be 35 and this will be 5. So it will be 20. To make it 5, 20 minus 5 means 15 ampere reverse direction will flow here. And it will be 20 plus 15 will be 35, so it will be 40 ampere again. And in the last step, what happened? The brush moved from this segment to this segment completely. Initially it was in this position, now this is in this position. So what happened? 40 ampere will be the current. There is no change in that because each coil produces same voltages and same currents, so there is no change in that. But this coil will produce a current of 20 ampere, and this will be 20 and 20 will be 40, and the whole 40 is collected here. This is far away from, this is the insulating medium, this is our insulating medium, only this portion is conducting, so nothing in this region will influence this brush because it is isolated. There is an insulation, it is isolated. So what happened? There is 0 ampere occurs, and there will be completely 40 ampere occurs in the current, and it again 40 ampere collected. That means simply commutation means, see my dear, here it was 20 ampere towards the right, here it is 20 ampere towards the left in the same coil. Am I correct? Here it is 20 ampere to the right and here it is 20 ampere to the left. In the same coil happens here. So commutation, in other words, you can explain like this. Commutation is the process of reversing the current in the coil. This is also called commutation. Or simple words, we studied earlier days what? Converting AC to DC is called the commutation. Simple. Converting AC to DC, that means there is an alternating current. The changing current is here. 20 ampere plus 22 minus 20. This minus 22 again plus 20, 15. The current is changing continuously, my dears. It is not constant. 20, then 15, then 0, then minus 15, again reverse in minus 20. That means the current produced. Suppose you focus on this coil only. If you focus this coil only, the waveform will be like this. What? 0 will be there. Maximum minus plus 20 will be there. Minus 20 will be there. In between 15 and 15 will be there. Everything will be there. That means the wave induced in the coil will be like this. But what is the output voltage? It is always 14 ampere. It will be AC. DC. That is, in simple manner you can explain this commutation as what? It is nothing but the change in alternating current induced in the coil to the direct current which is collected in the brush is called the commutation process. Or in other words, my dears, this is nothing but the reversal in current in the coil occurs. Commutation is the process of, irrespective of the reversal in the current in the coil, we are getting a constant current in the output through our brushes via commutators. Is called the process of commutation. Is it correct? So commutation means changing AC to DC simply, or the reversal of current in the brushes happens and in the output there is no reversal, it is constant all the time. That process is called, my dears, commutation. That process is called the commutator. We already studied split ring commutator, slip ring commutator, and we already learned that simple diagram. We learned like in dynamo, right? In the 10th or 12th you learned already. So the elaborated version is nothing but this. There was simply 2 commutator segments, so you can easily convert that AC to DC, but here are so many commutator segments, so that the concept will be small. I mean, it is an expanded version of the old concept, but the analysis will be slightly difficult. That's so the diagram itself will give you a wonderful meaning of what is commutation is. Okay, is it clear, my dears? Okay, can I rub this? Listen, my dears. So listen. So this is the concept of an ideal commutation process that I already explained now. From plus 20 towards the right to the complete reversal, minus 20 happened. In between 0 also came. So we concluded that the coil, the inside, I mean there is an induced EMF which is alternating in the in nature, which is induced in the coil. But as an output, as an output, what happened? The current is always constant. That means there is a commutation occurs. Okay, there is a commutation occurred. So what happened in practical case, in real case, what happened, my dears? I will explain. See the case here. See the case here. Suppose even in this condition, it is expected that right side 22, left side arrow 20 will be completely happen. This is our expectation. This is the case of ideal commutation. What happens? See, even though this is not a perfect insulator, correct? It is assumed that it is a very good insulator. Okay, mica insulation is there between the commutator segment. Okay, mica insulation is there, and carbon brushes we are using. Okay, not mica, some insulation, some very good insulation is there in between the commutator segment. Okay, and what happened? This insulation is not perfect all the time. This insulation is not perfect all the time, because the machine is continuously moving with a very high speed, nearly 1500 rpm and all. It is moving. So due to this high speed and all, this is happening in very fast, or which is the time duration for this reversal of current is very, very few, or in the terms of micro or millisecond. At this time it will continuously rotating. So what happened? There is always, even though it is in perfect insulated position, there is always some leakage current here. There is always some leakage current here. That means we assume there is no current in this should be 0 ideally, but practically there is some resistance in between. I mean there is a leakage current in between this portion. As a spark, my dears, as a spark, because you know that this is a conductive medium and this is a conductive medium. If it's very high current conductive medium, if it is in separated by a small distance now, there will be a spark and the conductivity will be there, right? There will be a spark and conductivity will be there. So like that a situation arises here also. Even if it is an insulating medium, even this is a perfect insulator, actually we are supposed there is no current through this portion, but due to the imperfection in insulation, what happened? There is always some current due to this region, and there will be a small current, say 5 ampere, suppose a 5 ampere current, or 1 ampere, my dear. You assume like 1 ampere current, you assume a small 1 ampere current will be happen. If here it is 1 ampere, means this is not 0, my dears, this will be 1 ampere. If this is 1 ampere, means 20 minus 1, this will be 19. This will be 19. That means, my dears, there will not be complete reversal of current happening in the coil due to sparking or imperfection in the commutator segment, or imperfection in the insulating material in between the commutator segment. There is always some spark occurs in the process of rotation of the machine. So at that time, due to that spark, there is a small current which is flowing to the brushes, so that there is not a complete reversal of current happens in that particular coil. That means there were some loss of current. My dears, even though the output is 14. This will make you what? This will make you again this 20 and 90, this will make you 39. That means there is no change in the output current. But actually under this condition, my dear, this is in perfect midway between, it is insulated medium and it is in insulator medium. But it is assumed that there should be 20, there should be what? Complete 40 to this. But due to the sparking, there will be always some small amount of current will be lost as spark. that lossage of current is reason for a bad commutation. Actually we are expecting this plus 20 to minus 20, then only it will be an ideal commutation. But what happened? Due to the spark happened in the brushes or in between the insulator and brushes, what happened? The current is supposed to be end at, now this figure my dears, now this figure, in this figure the current is supposed to be end at 19 ampere, not in the what 20 ampere. The current ends up with 19 ampere. So the spark, no, the difference is no, that is due to the spark. So this voltage is nothing but 1/4 of the total voltage, and this voltage is nothing but 3/4 of the total voltage. Okay, 3/4 of the total voltage. It will be very easy if you take it at 15 my dears. That's suppose you take it as 5 and this is say 5 ampere. Okay, it will be very easy then only, that's why. Okay, the spark, due to spark there is a 5 ampere current you imagine, and it will be again 15. Okay, 15, that is very easy for the concept of this fraction, and taking this fraction it will be very easy. If you take 1 it will be slightly difficult, no, that's why. So plus 20 to minus 20 will be the actual case, but what happened? Plus 20 to minus 15 only happening there, minus 15 only. Actually we are supposed to here at 20, but actually it is 15. So 5 will be there, 5 will be where, 5 will be where, 5 will be lost in some other manner. Not in the sense loss means it is not utilized, it is utilized here, but as far as the meaning of commutation it is not utilized na. As far as the meaning of commutation it is not utilized. If it is exactly utilized means, if a perfect commutation means plus 20 here to minus 20 will be here na, minus 20 will be here, but due to the sparking effect, the output will be 40. There is nothing lost in the circuit. We get the 40 output as 40 ampere at output, but the commutation is perfect or not? No, the commutation is not perfect. The commutation is not perfect here. The commutation is not perfect here. That means there is a distortion in the waveform inside itself. There is a distortion in the waveform inside itself. What happens? This will happen. So plus 20 to minus 20 actually we expected, but in actual practice it will be simply minus 15. So there will be some spark occur. That spark is the reason for this 5 change. This 5 dip, no, 5 ampere dip. The reason for this is nothing but the spark. So what happened? 1/4 into 5, that's 5 ampere will be lost as spark, and 3/4 into 20, 15 ampere will be the remaining output. I'm again saying my dears, the loss in the sense, the commutation loss, not the external output loss. Okay, nothing is lost here. We will get the 40 ampere at super output. No issues in there, no issues there. But as far as the concern of the commutator segment, what happened? There is a problem in the commutation. There is a problem in the commutation. That is the reason why that dip in current, that change in current, that perfect change in current is not happened here. The perfect change means plus 20 to minus 20. This will be minus 20. But what is instead of that? It is simply 50. Am I clear? Am I clear? Or in simple word, my dear, or in simple words, my dear, suppose you consider for the waveform, this should be plus 20, this should be what, my dear, this should be minus 20, but it's not there, it will be in between, minus 15 will occur. That means there is a distortion in the waveform, there is a distortion in the waveform, there is a distortion in the waveform. But the average value is collected as 14 ampere due to the neighboring commutator helping only, it will be 14 ampere due to its own help. That is the meaning why the loss in the sense of commutation happens, but not in the sense of the output voltage. So the output current, there is nothing lost in the output current, but there will be a loss in the commutation. There will not be a proper commutation. That's why this happens. Very difficult to understand, I know. But anyhow you have to understand this, okay? Anyhow you have to understand this. There is no rickshaw from this, right? You have to understand. Is it clear? Is it clear, my dears? So this is called the failure in commutation, correct? This is called the failure in commutation or bad commutation, or we call it as bad commutation. Okay, my dears, did you get my point? Did you get my point, my dears? Okay. Next, reactance voltage, my dears. Reactant voltage is very, very important though. Reactance voltage. What do you mean by reactance voltage? See, my dears, consider the middle coil, this coil. Focus on this coil only. Focus on this coil only. What happened? Initially, this coil current was right side 20 ampere. Then slowly right side 15. Then slowly right side 0 happened. Then slowly left side 15. Then slowly left side, actually for ideal left side would be 20. In which means, see, minus 15, 0 and there plus 15 and plus 20. Focusing on these will give you one idea or will give you strike something that the coil current is changing continuously. The coil current is changing continuously. Coil is nothing but inductive in nature, right? Coil is nothing but inductive in nature. So if the current changes in the inductor continuously, what happen? There will be an induced EMF or back EMF in the inductor itself, because that will changing continuously. Or in other words, the property of the inductor is such a manner that it always opposes the changing current through it. That is the property of an inductor. The property of an inductor is in such a manner that it will always opposes the current, change in current through it. That is the meaning of an inductor. So as far as that inductor, that middle inductor concerned, there will be a current which is changing continuously. What is the change in current, my dears? Change in current is nothing but plus 20 to minus 20, or simply change in current is 14 ampere, 40 ampere. Am I correct? For ideal commutation, my dear, for ideal it will be 20, okay na? So 20 to 20 minus 20 will be 40 ampere. Suppose the time taken to this change is called Tz, is called the commutation time. Is called the commutation time. Then according to the Faraday laws of electromagnetic induction, whenever there is a change in current happens in the inductor, that inductor will produce itself an induced EMF in opposite direction, or to oppose the changing the current through it, there will be some induced EMF. That induced EMF is nothing but, my dears, VL. Let be VL is equal to L into di by dt. You know this, right? Minus L into di by dt, correct? Am I correct? So definitely that should have some inductance value L. Di is nothing but, my dears, 40, correct? 40 change in current will be 40. So minus 20 will be minus 40 na. So it will be minus 40 na, change in current. So divided by dt, dt is simply Tc. So this will be the voltage which is developed in the coil, my dears, within the coil. That voltage will be definitely opposes the reason. Reason for the change in current is nothing but the rotation. The rotation reason is nothing but, as far as the concern of motor na, it is the applied voltage. The reason for the rotation is the applied voltage. So for motor, these EMF will be opposing the applied voltage. As far as the case of a generator, it will opposes the rotation of the a generator. That voltage itself, and definitely these voltage will be opposing in nature. So it will be, in the case of a generator, my dears, it will opposes the induced EMF in small fraction. That is the reason why there is a small dip in the induced EMF na, due to armature reaction. I already explained na. This is one of the reason. This is also one of the reason to the dip in voltage, dip in voltage in the induced EMF. Okay, so that reactance voltage is nothing but this is a voltage induced by the armature coil due to the change in current through it, and this will lead to the overall decrease in the what? The induced EMF in case of generator, but in the case of motor it will oppose the back EMF. It will oppose the back EMF. Okay, so this is called the reactance voltage, my dears. Reactance voltage. Okay. Next we have to see how can we improve the commutation. How can we improve the commutation? Next, methods to improve commutation. Methods to improve commutation. First method is resistance method. Or resistance commutation idea. Resistance commutation. Draw this figure. See, my dears, so what happened here it is resistance commutation means we are now going to discuss method to improve that problem. Now there is a problem that complete reversal is not happening. That means there is a spark, right? There is a spark. So we have to reduce that spark. We have to reduce that spark. So that what we are going to do. The first method is that what we are going to do is this. Suppose the resistance here it is nothing but, or the spark resistance is nothing but R1. Due to some resistance there is a spark now. So this is a resistance or insulating medium. This is also insulating. This is conducting. Make sure that R1 will be very less than R1 will be very greater than R2. If these conditions satisfy, there will not be any spark. That means make this insulator as stronger as possible. Make this insulator as stronger as possible so that there is a perfect insulation in between these two commutator segment happens. So what happened? There will not be any spark. If there is no spark means if it is in between these two commutator, I mean this insulating brushes, insulating medium, the brushes will be completely short circuited by this commutator segment and complete 40 ampere will be flow like this. There will be no 0 ampere. So there will be a perfect commutation. That means there will be a minus 20 happens. So if this minus 20 means there is a complete reversal of current happens, and this is called the resistant commutation. Resistant commutation. It is not actually practically used. It is not practically used because super methods are there. We will discuss one by one. It is not practically used. Because now making this a perfect insulator like condition now it's very difficult. Even if we make a very good insulator there will be a chance to spark, because this much high, suppose as far as the high current machine, even if you make it as a perfect insulation condition, then only there will be spark. Even only vacuum can be adjust to somewhat a perfect insulated condition. But otherwise, if you use any other material, paper, mica or anything, there will be some there will be some spark happens and there will be some losses. Okay, and the practically used methods are called the voltage or EMF method. The practically used methods are called the voltage or EMF method, my dears. Voltage or EMF method. Okay. I'm asking you something. Actually, what is the reason for this ineffective commutation? What is actually the reason? Where is the reason for this ineffective commutation? What is the reason? The reason is nothing but the armature reaction. Wherever there is a flow of flux or flow of current or high current in the armature coil, that armature coil is the best reason for the commutation failure. The armature reaction, indirectly the armature reaction is the reason for the commutation failure or the ineffective commutation. So our primary preference is to reduce the armature reaction, not reducing. This is nothing but the external, already there is imperfection, but we are trying to make it into the outside region. But if you try to make it clear or make it correct in the inside region, that will be the best option. That will be the best option. So voltage or EMF method is used to rectify the problem in the inside itself. That is to avoid, to overcome, to reduce the effect of cross magnetizing effect of armature reaction. Is very specific. Very specifically, simply you can say that the armature reaction. Okay, that's also acceptable answer. But if you strictly speaking, the cross magnetizing effect, because not demagnetizing effect, my dears, cross magnetic effect is a very big problem, because that is the reason by the tilting or the alignment of magnetic lines of force in not normal manner, right? That was the reason, cross magnetizing effect. So voltage or EMF method, we are going to do what is that we are opposing the cross magnetizing flux by using another flux, by superimposing it on it. We are opposing the cross magnetizing effect of or simply the armature reaction. We have to oppose the armature reaction, my dears. That's all. Simple words. We have to oppose the armature reaction. Then what happened? There will not be any armature reaction. Then the things will be very smooth. The commutation will be very smooth. Because I already know reactance voltage. The term reactance voltage. What is the reason for producing that reactance voltage? The change in the current in the armature coil, my dears. The change in the current in the armature coil. Correct? And that current is not perfect. There is a loss happened. There is something lost. That reason why the losses happened is nothing but the imperfection or the not uniform distribution in the magnetic flux in the pole phases or in the pole region. That is the reason why there is a tilt or there is a inclination of flux lines in the main field flux happen. That is the reason why there is an armature reaction. So ineffectively we have to reduce, my dears, armature reaction. If there is no armature reaction, means there is no spark. There will not be any spark in the brushes. The things will be very smoothly. You can change from +20 to -20 very smoothly. You can change. Very smoothly you can change. So two reasons for the spark occurs. Externally we can adjust with the resistance and all. We can explain in that manner to the term spark. Or in other words, internally itself the reason for the change in current is nothing but the reactance voltage. The reactance voltage. My dears, okay, I will explain in terms of reactant voltage now. See, the current is here supposed to be 20. Am I correct? The current here is supposed to be 20. There is a small current of, there is a current change of what? 15 only. That means there is a dip of 5 ampere happens. Why this dip of 5 ampere happen, my dears? Due to the reactance voltage, because that voltage is opposing the original voltage. If it is there some high voltage there, suppose nothing is there, means it can easily flow like this, right? The current can easily flow like this. Suppose here it is high voltage is there. Someone is here also heavier manner. That voltage can easily flow now as that of before case. No, there will be some resistance. The current will be not be 20, the current will be 15, because that extra 5 ampere can be pumped by oppositely by the one, this process, no, this process. Am I clear? This is the normal, root to Faraday's laws of electromagnetic induction and all. There will be some voltage and there will be some current, but there is a reactance. There is a reactance voltage. So due to that reactance voltage, the current will be dipped, the current will be low. That also the concept of armature reaction. That also the explanation for this 15 ampere radius. Okay, is the two way you can explain this. I already told you this is very difficult concept to understand. Okay, simplest manner I am going to explain all this. Okay, if you found anything simpler than this, you can comment in the comment section. Okay, I will consider that also. Okay, so next we are going to voltage or EMF method. So what we are going to do, we are opposing the armature reaction. Now we have the aim is to oppose the armature reaction, my dears. Aim is to oppose armature reaction. Okay. First one, by brush shift. The first method is by brush shift, used in older days. What was that? I already explained it. We have to place our brush exactly in what? Magnetically neutral axis. It is not practically used, my dear. It is not practically feasible, because whenever the load is changing, the armature current is changing. Whenever the armature current is changing, the effective armature flux changing. So we have to search for new MNA every time. That means even if you fix some MNA and place our brushes there, if you change the load, then that MNA will be slowly changing from that position. Then also there will be a spark happens. Then also there will not be smooth commutation. So this is the brush shift is not used in the older days. This is used in the older days. And second method is nothing but, my dears, it is called the interpoles. By using interpoles. Draw this figure. Listen my dears. Okay, listen. So simply in examination and all, I am again and saying this diagram will not be asked, but certain points will be asked that I will explain only. Okay. So the interpole means there are main pole. Suppose it's a two pole system. There are main pole N and S. So main pole is energized by some external DC supply, field supply, which is called a DC supply, right? Which is connected in series and N and S wounded. Interpole means the poles in between the main poles all called the interpole, and the connection of interpole in such a manner that it is in series with the armature. This is armature coil, my dears. This is armature coil, okay? This is armature coil. So interpole connections are in such a manner that it is in series with the armature coil. It is in series with the armature coil, and the winding is made in such a manner that for generator, suppose this is rotating in clockwise direction. The polarity of the interpole is same as that of the forwarding pole if it is a generator, and it is a motor. I will explain here. For generator, the polarity will be same as proceeding pole, or for motor the polarity will be same as back or similarly, upcoming pole and back pole. I will explain that. For generator, what happened? The polarity of this interpole is such a manner that suppose in clockwise direction is moving. What is its next main pole? Suppose is S means this also S. For generator, this is the case. For motor, suppose the motor is moving clockwise direction, then the polarity of this pole will be taken as the back pole, same as the back pole. Suppose it is moving clockwise direction, so back pole means this will be N, but that's all. Okay, for generator only we are taking consideration. For motor is the reverse case. Okay, so what is our aim is to that we have to reduce this armature reaction effect. That means the reason there was initially phi F, and there is always some phi A, in which there is some phi C also, cross magnetizing flux also. So we have to reduce mainly this cross magnetizing effect. The majority of the phi A will be phi C. Okay, so you can take phi A directly also. So we have to oppose this phi A by inserting some compensating winding, interpole. This is called phi I. Phi A is nothing but interpole flux. So what we are going to do is we have to apply an opposite flux as that of the armature flux here. So if you apply an opposite flux to the armature flux means this phi A will not be there. This phi A will not be there. Am I clear? So there will be a perfect EMF induced. There will not be any dip in the EMF induced as far as the generator case. That means if you take a conductor which is moving inside of the magnetic field, there will be an induced EMF plus. There is nothing to oppose this induced EMF there. If a conductor is simply rotating in a magnetic field, there will be some induced EMF now. That induced EMF will be complete, you can take it outside. The reaction, the armature reaction and all leads to the dip in the induced EMF in the generator, in the case of generator. So that dip will not be there if you directly opposes an interpole flux with the armature flux, so that the connection will be adjusted in such a manner. The connection will be adjusted in such a manner which is connected in series, so that whatever may be the induced EMF produced, armature flux produced in the armature conductor due to the current IA, the opposite flux will be produced by the interpole, so that two will be cancel each other, and there will not be any armature reaction, so that there will be a smooth commutation process happen, and we will get a super duper output. Is it clear? Okay. That means I can say like that. As load increases, IA increases. If IA increases, phi A will be increases. If phi A increases, phi I also increases. So there is no armature reaction. And there is no tilt in the main field flux. There will be uniform flux distribution across the pole faces. So it is super duper output will be there. That's all it is. So that is the concept of by using interpole. Okay, by using interpole. Okay. Next, by using compensating winding. Next method to improve the commutation is using compensating winding. Draw this figure, my dears. Okay, listen my dears. By using compensating winding means, see, this is the armature and there will be some conductors in the armature. Suppose this will be cross because it's in N pole, under N pole, and this will be S. So dot means current inside the coil. Suppose it is in under S pole. So what we are going to do is, actually this is the reason why the production of armature, this alternately flux produced in the conductor is the reason for what, my dears? The armature reaction, correct? If this is not there, the flux will be smooth and super, and there will be a super fine output. But if it is there, we are face a problem of armature reaction. So we have to eliminate this, right? We have to eliminate this, correct? We have to eliminate this, means the effect we have to eliminate. So what we are going to do for eliminating this is that we have to make sure that there will be an opposing flux which is produced. That flux is provided by inserting some windings on the pole faces, and the current in the pole face winding in such a manner that it will be opposite to that of the current in the armature. See, this is dot, this is all cross. This is cross, it's all are dot. So in such a manner we arranged certain winding so that we can reduce the effect of armature reaction and we will get a good defined, well defined output. Okay, that is the concept of using interpole winding. Okay, my dears, so that's all for today. See, in this all are theory sessions. Only examiner will ask you what is meant by and what is meant, like that question will be explained, not in deep, that much deep you can't expect there. So don't worry about that. Even if you feel some confusion here, simply neglect it. You can find, definitely you can search your Google or YouTube, anything, no issues there. But even if you feel very difficult to understand this, simply just ignore it. Okay, will not be asked, a deeper question will not be asked here. Okay, so that's all for today, my dears. So let's meet again tomorrow with a new session. So until then, bye.